We are going to take a look at some real examples of quadratic functions. Keep in mind that quadratic functions produce U-shaped graphs. The graphs can open up or they can open down. In projectile motion problems that we're going to be looking at, they open down, so they have negative a values. These are some examples. So let's really focus in on one example and what we can see when we look at it, that shape of it on a graph. So here's some guy shooting a basket. Let's start by labeling our X and Y axis. So remember, the X axis is horizontal. Our X axis is actually going to be telling us time. The Y axis, which is vertical, is going to tell us height. So I'm going to just label those for you. We're going to look at this picture and figure out what's going on. So starting height. Well, the starting height is where this guy's throwing the ball. So it's going to be kind of somewhere over here is the starting height. The max height is going to be the maximum height the ball goes. Well, I'm going to guess that's somewhere around here, just from this example. And finally, I'm going to estimate that the ball is going to hit the ground around here. So this is some information I can find from the graph. So this is what it's going to look like in a real life situation. Let's take a look at it in our notes. So please open up your modeling quadratic notes in Google Slides. And we're going to be focusing on projectile motion here. So I'll go back and forth to the slide I just showed you so we can figure things out. So the first things I want to point out, again, is our x-axis is time and our y-axis is the height. These are your x-intercepts, the spots where your graph touches the x-axis. This is the vertex, where that curve is in the graph. And this is the y-intercept, where your graph touches the y-axis. Now I want you to notice over here, when we think of our graph, these are positive x's, these are negative x's. It says here to ignore the negative x-intercept for these kind of problems. Why would we do that? If x tells us time, why would we ignore the negative x's? We're going to ignore them because you cannot have negative time. That doesn't make sense unless you have a time machine. So let's talk about what we can find out from this graph. And I'm going to give you some cues of questions you're going to see and where you could look at a graph to find the information. So let's talk about this y-intercept right here. Well, we said that is where that starting height is, where our graph starts. So that's going to be our starting height. So a question you might see where you can use that information from your graph is, how high off the ground did the object start? So that's your starting height. A y-intercept is always going to have an x value of 0, and that y value will be that number you see on the graph. Let's take a look at our vertex. So this is the vertex, and I'm going to actually put an arrow in there for the vertex. It's that point. It's where that curve is on our graph. So the vertex is going to have an x and a y value because it's a coordinate, just like all of our other points. We already looked at this graph, and we saw that this was our max height up here, the maximum height our parabola will have. So that y value will tell you what the maximum height is. So a question you might see would be, what is the max height of an object? You can find that by looking at the y value. We know that x tells us time, so that x value would tell us when the object is at the maximum height. So all that will be information that you can find from the vertex. The last thing we're going to look at are these positive x-intercepts. The coordinate will always be some x value, comma 0. The x-intercept is going to tell us that x value tells us time. So we know that the ball is hitting the ground here. It starts here, or whatever our object is starts here and hits the ground. So because it's time, it's going to tell us when the object hits the ground. So that might be a question you see. Or it might tell us how long the object is in the air. So those are the types of questions you would see if you need to look at the x-intercept.